I think so, yeah.
All right, why don't you get the lesson? I'm sure it will tell you those three things somewhere in there.
Okay. Let me see. Yeah, I'm looking. I have it open right now. I'm looking for what atoms are made up of.
Why is it paused? Okay. I'm gonna get your to get it open as well. That maybe we can look at it together. Okay, I don't have that.
Oh, I don't see it where they mentioned where. Wait, let me see. Well,
Would you put your password in the chat one more time for me? I don't seem
okay.
to have it. Uh,
Do you want the username too, or is the username saved?
Username was saved. I don't know why I thought I set up a secure browser for students like yourself, and I don't know why this one didn't save it. We're gonna save it this time though. That's gonna make this. Oh, that doesn't even give the option.
Hmm.
Let's see here. All right, there it is. All right. Lessons. All right, so we're up to the atom. I'm gonna new share this so you can see it here. All right. So the atom. Okay. Well, did you watch the video?
I did not have time.
Okay. Let's see what it would take to watch the video. How long is it here?
It's like, oh, 21 minutes.
Yeah, so we're not going to use our time up for that, but what the expectation for me would be, hey, let's at least watch the video. Let's find time
Yeah.
in the car or, somewhere. I mean, it's all the questions are from the video, meaning 20 minutes of watching it. This one is 10. That's I don't know, 30 minutes, and we could answer most of the questions here. So, all right. So since you did not watch the video, what we will do instead is I will ask you to write a sentence that says that the three particles that make up the atom include the protons,
Oh,
neutrons,
and electrons.
and electrons. There you go. So what I'd like you to just put together a sentence for me for that. That answers the question. It's a full sentence here, please.
Okay. Okay, I just sent you
Right.
my sentence in the chat. I think it works.
Yeah, that's good. Right. Very good. Okay. So where are they located in relation to the other? Okay, so the uh, protons and neutrons are located in the nucleus, and the protons are in the outer shell or shells, we can say. There could be multiple shells. What is their mass in relation to each other? So what I want you to do is a quick Google search on the mass of electrons, neutrons and protons, please.
Okay, it says the mass of a neutron is one. The re- and the mass of a proton is also one, and for electrons it's 0.0005.
Okay, so we got to be careful here. We're not actually looking for the actual mass. We're looking for the
Oh,
relationship between them. Basically, how much bigger or smaller are they compared to one another?
okay.
And so I don't know if there is a good, yeah, this is maybe the best. So one of the things I've done more lately with students, especially, is when I look something on the internet, I know we go just right to the first uh, hit on the internet, but the images are really good. If you go to the images and you spend a little bit of time, somebody has already answered this question. They've made a really cool table in this case that helps you to see that the mass of a proton, let's say the mass of a proton is one, the neutron is one. How does the electron mass compare to the proton and the neutron?
Um,
How does this number compare to these two?
I don't know actually.
Okay, but well, tell me which one is bigger, which one is smaller.
I would
Well,
say that the 1/2000 is smaller.
yes, it's a lot smaller.
Yeah, because it's a fraction. It's not
Yes,
even a full number.
it would take 2,000 electrons to make up one of these. Okay, so I'm looking for a sentence that says the protons and neutrons have approximately the same mass, but the electron is and there's a couple of ways you could say it, but you want to say that electrons are a lot smaller in mass than protons and neutrons.
Can you repeat that one more time?
I'm asking you to summarize the results in this table, specifically this last column here.
Okay.
So what do
Like
you see? The mass of a proton is
the
one, the
mass of it.
neutron is one, but we want to write a sentence about the comparison. We want to say that they're the same.
Yes, but so we would say that a proton and neutron are the same mass, but with an electron,
Well, you might say
it's
they're
more.
approximately the same mass, because that is the truth is they're
Okay.
approximate, the same. But the electron is much, much smaller.
So would like this is the sentence that I wrote.
It's correct, except you're not emphasizing that the electron is a lot smaller.
Do I mention the fact that it would take like 2000 of.
You don't have to be specific. You just want to say that it's a lot smaller.
Okay, got it.
Just maybe add a little bit to that last.
I just said it the electron is a lot smaller, but I can add more because
Sure,
I
that
don't.
that's just that one extra word is important.
Yep.
Okay. All right, good. So now the last thing here is what are their charges? So that's in this column here. Could you put a sentence together with the charges, please?
Mhm. Does this work for the sentence, by the way?
Electron has a negative charge, a neutron has a charge of 0, and a proton has a positive charge. Good. Yep, that's correct.
Awesome.
All right. All right. So that answers question 1. All right. So the next one, much tougher to answer. You definitely need the video. So how do you know what element an atom is? Maybe you've seen this before. This is the periodic table of elements. Maybe you've actually just seen it.
I've seen
Um,
it in my when I used to go to like my public schools. I used to see a chart of it.
okay. The number above the letter is it's called the atomic number.
Mm-hmm.
Okay, so that tells you that that's the answer to this question. How do you know what element an atom is? The atomic number is the number of protons and and explains which element the atom is. So we're going to start with hydrogen because it's the one on the top left. Hydrogen has an atomic number of 1, meaning it has 1 proton.
Wow. Okay. Does this include an example?
That's hydrogen.
Yeah.
You can be specific and say an example is hydrogen, or it's implied that you're giving an example if the person reading it knows what example to look for.
Got it.
It's a shortcut in writing if you're, if you're okay with it. Okay, what information is in each box on the periodic table? All right. So periodic tables have um, more information than this. Some have less. Depends on the complexity of the table itself. Um, what we don't know is whether they're referring to this table, which is probably reasonable. Although, because you're supposed to watch the video, it might be that they want you to include like more information. We can keep it super simple and go with what information is in here in the table. So I'm going to put in the chat what we already talked about the first thing. Oops. First thing is the atomic number. Okay, so that
Right.
that number above the letter is the atomic number. That's the first thing. Second thing is the letter. The letter tells you the element. The third thing is the
The color.
all right, so we can also talk about the color. Color is the type of metal.
Okay.
So what I would like you to do is put together a sentence that has all of those pieces of information, but is more descriptive than what I've done.
Okay. Like I'll try.
You also should really say, give the confusions. Um, like the one, like the number above the letter, the number below the letter, that would be preferred way of sort of.
Okay, here's what I wrote.
All right, pretty good. I'm just going to add a few words to kind of
Mhm.
clarify a couple of things, but this is really good. And
Thank you.
more, what we're really trying to do is just get you more comfortable writing sentences. I mean, that's really here- here- uh, all this is. So periodic table includes a color for the type of metal, a number above the letter for the atomic number, the letter for the element, and let's say it this way, representing the element name, and the
Yeah, that
mass,
works.
which is the number located under the letter. All right, perfect. Okay. What is an isotope? So this is kind of a straight, definition. Um, Let me kind of help here. All right, so I don't see anything in the picture, in the images that's going to make this easy to, it's very much a definition, and I guess you can just use the definition is what I'm thinking. Um, Let me snip something in here, I guess.
I just searched up an example of it. How do you say isotope?
Yeah,
And
isotope. What is an isotope?
yeah, and they only mention examples from what I've searched of radioactive ones, including carbon,
Here,
chlorine, uranium.
so just a straight definition of an isotope. Maybe you could put that into the chat, and then you can use carbon as a an example of an isotope if you want.
Yeah, I can do that. I'm just making sure. I'm just right now checking the lesson to make sure if they have any examples in there before I write something down. Sorry, that's my dog's barking right now.
Yeah, no problem.
My parents just left and he just started barking. I am so sorry.
No problem. Just take your time if you need to do anything with the animal. Just take care of it.
Yeah, hold on. Just let me go get him to calm him down because I can't focus. And if he's barking, I'm so sorry again. Okay, I'm back. I'm so sorry. I just finally got him to calm down.
All right.
Okay. Um, what is it? So should I search up the definition of an isotope and then
Yeah, exactly.
like
Yeah, exactly. That's
okay.
what I'm looking for because it's just a pure definition. You can write almost exactly word for word whatever you find.
Okay, cool. And then I'll mention the example of, you know, All right, here we go. I wrote down the definition, then include the example.
Isotope is two or more fork. Okay. So we got to be careful here. With two or more fork sounds pretty
Oh, I
pretty
didn't mean to
formal.
put four.
What's that?
I meant to put four. I meant to put four, but I was typing and I didn't notice my spelling errors.
Okay. What did you mean to put there instead of forks?
I meant to put four.
Okay, that's definitely not correct. It's types the same element that contain equal number of protons, a different number of neutrons in the nuclei. You want to avoid words that sound here. Uh, so what we can do here, kind of clean this up, is say that an example of an isotope is uranium, which has a radioactive form of an element. What we've done here is basically take like it's okay to write a pure definition. That's okay. Like that's not cheating. That's not plagiarism. If it's definition, it's definition. So you don't want to just pure copy and paste. It's it's whatever you you just gotta kind of re-massage it just a tiny bit. All right. Okay, so most of the atom's mass is in the nucleus. And we know that from earlier because protons and neutrons have the most of the mass. Electrons are much smaller. All right, so I hate saying that you're gonna have to watch the video. Um,
Yep.
now sometimes you can go to the video and look at the comments, and sometimes it's there.
Sometimes, not all the time.
Sometimes not all the time. So I'll leave that up to you. But that would be worth you know, unfortunately you'll probably have to go look or not answer the question, which would be okay. All right, so look
Yeah.
at the charge on each of the three subatomic particles. Which particles each particle attract and repel? Okay. Um, what do you know about positives and negatives?
What I know about positives and negatives?
Yeah.
Um, well, I know that a positive, I mean, it, wait, oh my God, wait, hold on. Okay, wait. Well, I know that a positive, are we, are we talking about mathematical or the scientific way? Like for,
Well, it's pretty open-ended. I mean, we're trying to answer this question, but I'm trying to gauge what you so like we can use it in a different context. What happens when you get cold?
oh, we shiver, we want to get warmer.
Want to
So
get
I guess
warmer. And
that's, that
when we get too warmer, when we get too warm, we want to
we want to get cold.
yes. So you can think of those as like pluses and minuses. Those attract each other. Positives and negatives attract each other. So that means electrons and protons, they attract each other.
I see.
So maybe start with that. Put a sentence together that says something about protons and electrons attracting each other.
All right. I guess when we have a break, I'm gonna have to try to watch the videos. Start and like that anyway. I can use the hot and cold example in the sentence, right?
You don't need to. You just need to say that a proton attracts an electron. Proton is positively charged. It attracts an electron, which is negatively charged.
All right.
Are you typing these in the chat or are you typing them in your own sort of Word document?
No, I'm typing them in the chat.
Okay, I would recommend typing them in another document because the spellings are, there's a couple of spelling things.
Oh
Uh,
yeah.
all right, now, does a proton attract a proton, which is a positive with a positive?
I would like to say yes, but I think that's a no.
So it's like uh I kind of try to think of an appropriate analogy, but the the be careful here. So positives, two positive charges don't attract each other, they repel. And two negative charges also do the same thing, they repel each other. So will you put something together, another sentence or two about how those two would repel each other? Like positives repel positives and negatives repel negatives.
I just typed in the chat again. Uh,
All right, I had stepped away for a moment. Looks like you put something in the chat there.
mhm.
All right, very good. Okay, so that's good. That'll be enough for this. Okay, what is the net overall or sum of charges of the nucleus and what number is it equal to? So the nucleus just contains the protons and the neutrons. So there's no electrons, so it's just the positive charges. So
Got it.
the net charge of the nucleus is, we already answered this, it's the atomic number. The atomic number, it's the number of protons, which happens to be the same number of, which happens to tell you the charge of the nucleus.
Gotcha.
So could you put a sentence together that says something like that? The overall charge is the atomic number, which is the number of, neutrons, or sorry, protons. Oh, I always get those.
So like the overall charge is the number of protons and
Yeah, which is the atomic number. So we're looking for something like that um, in a sentence.
so I can't just say like, well, we said where the overall charge is the number of protons, which is the atomic number. Like, should
Yeah,
I
that
add
that
more?
that sounds okay.
Okay, cool. I just sent it in the
Sounds
chat
like
as well.
the overall charge is the number of protons, which is the atomic number. Yeah, that's it. Nothing more, nothing less.
Exactly.
Okay, why don't you do a Google search for number 9? What happens when an electron gains more energy?
Okay. So it says here, when they gain energy, they jump between shells as they are rotating around the nucleus.
Okay, so we gotta be careful here because the fact that there was a video we watched, and like sometimes instructors get pretty frustrated when you don't like include what was in the video.
Right.
Uh, and I would always kind of like talk to you about like going to the images, because sometimes the image tells you the same thing, but you can sort of say it differently. Wow. Or you can say it without, just copying and pasting what's the first thing you see on the search engine. The picture here, I think, really is kind of cool. It also leads to the next question, which is a shell. These are each just shells. Okay. So when an electron gains more energy, you're right, it sort of increases the level of this. Um, and the consequence, well, it could be negative, could be bad. Uh,
Really?
yeah, these things called photons can like be dangerous. You've heard of splitting atoms. I mean, that's the atom bomb. These things could be dangerous. So when they gain more energy, they become unstable. So I would put together a sentence from what you just read out loud, and then also um, say that the consequence of this is that the atom could become unstable.
Okay. Gotcha. Okay. So it says they jump around. Okay, got it. And this could lead them to getting out of control, right?
Unstable is kind of the best word there for that.
Okay.
It sort of implies a lot of negativity. Uh,
And we don't want negativity.
we definitely don't. Uh,
Yeah.
right. When an electron gains more energy, they jump between shells as they're rotating, and this can make them unstable. Yeah, there you go. I mean, have you had any feedback yet on these that has been negative?
No.
Okay, that's good. All right, what is an electron shell? That's kind of a pure definition. So if you want to look that up, it'll be whatever you see. There's no, you don't have to massage it or rewrite it. You just go with it.
Yeah, okay. I'll find what an electron shell is. I'll type it into the chat after that, and then okay.
So
Give me a second. It says here an electron shell is um the dis the discrete region occupied by electrons around the nucleus of the atom.
yeah, so more generally, it's the region around the nucleus and it contains the electrons. Try to put that into a sentence or two.
Okay, the first thing I said was an electron shell is the region around the nucleus. I should mention the fact that that's where electrons are stored.
Yes, exactly.
All right, there we go. I just typed it in chat.
Okay. Yeah, that's good. That's really good. Now, on my page, you probably saw on the previous one, see how this kind of goes to the right?
Mm-hmm.
This is like a formatting issue. I don't know if you want me to fix this or,
No, it's okay.
okay. All right. What is the atomic symbol, period it belongs to, and number of occupied shells, energy level for each? So there's going to be a website, and this might be it. I'm gonna go to this website first and see if it's the right thing. Um, we're looking for period it belongs to, occupied shells. I don't know that there's something that's going to give you all of that information at once, but there should be. Energy levels. I'm just looking on the other, the other page here. Okay. Interactive, periodic table. Let's see, we want the period and we want the shells. All right, I don't know that we're going to be able to get this. I don't want to overcomplicate this either. See, I'm just looking ahead here to see what else you might have here. Okay. All right. So why don't you look up the atomic symbol for hydrogen? Maybe you already know it. You can just do a search on that.
The atomic symbol for hydrogen, that's what you want me to search up?
Yeah.
Okay, cool. The atomic symbol for hydrogen is an H.
Okay, now the period is the column that it appears in. So the first column here is period 1, period 2. All of these
It's
in the yeah, and then all of these are actually considered 3.
really,
And then what?
that's so cool. I'm sorry, the periodic table is really cool.
4, 5, 6. I'm sorry. No. This is not the right table for me to look at. Sorry, I don't like the one that they've given you. I use a different one with students when we're actually doing period is the column. So what was your 4? Okay. Yeah, there's 7 periods. Okay. Um, I'm trying to find something that will help to like make it clear, and I'm not seeing that. Sorry. So this is what we want. All right. It's this like the challenge of what we're doing is like you need like a little bit of information, which the videos do provide. But if
Yeah,
we don't have that, then I have to go search for something here. So this is the best picture I could find. This actually is everything we want. Although H is in a weird place. H is supposed to be there, but period is the row basically. So
got
hydrogen
it.
is in period 1. Okay, and then gold. I'm sorry, a number of occupied shells. So that's where it gets more confusing. You may just want to do a search for hydrogen and the number of occupied shells. There's what's called a configuration, uh, and I don't think that that's what they want you to do here. They're called orbitals. I don't think you're supposed to know that.
Hmm.
Um, so let's do this here. Let's actually just pause here. We'll pick up in about 10 minutes and we'll just keep figuring it out. So grab that other
Great.
link and we'll start working. All right. See you soon.
See you soon.